In this session, we are going to build a job scheduler using scheduling algorithm FIFO, that is first in, first out. For that, we are going to make use of a run queue, so-called a message queue. We are going to enqueue jobs at the rear end of the queue and dequeue jobs from the front end of the queue. Let us jump into code right away. We're going to have slice of job. I'll call this as job queue or job scheduler or run queue or whatever. We can call it anything. So this is going to be a run queue for the jobs in the scheduler that we are going to build. Okay, and this needs to be small j. So we are building job of slice. Next, we are going to perform NQ operation, meaning we are going to line up the jobs in the queue, and let's create a wrapper for that. Create a new job scheduler. NQ operation, and then create a scheduling operation. This is what is DQ operation. Then we are going to have a constructor that's going to instantiate the job object. instantiate the job queue. So I'm going to keep this with smaller case, job queue, and this one with smaller case. Okay, let me close this. All right. So this is as good as constructor. And then I'm going to have the function main, which is going to be the driver for the scheduler. And then maybe depending upon the need, we'll see a list function, but I'll keep it as optional as of now. Function constructor, and that's going to build job queue. I'm going to return job queue and instantiate that with job type slice. Let me keep this a smaller j and this one also a smaller j. Okay. I'm going to have run queue here and we'll call constructor and this is instantiating or creating the job creation of the job queue. Now go to insert or invoke job and then schedule them one by one. So the scheduling algorithm we are going to follow is first in first out. There is no priority. So the one that comes first is the one that gets scheduled immediately from the queue. So we are going to invoke job. There can be jobs as in maybe applications A, B, C, and so on. We have seen in our overview section, application can be anything between Chrome, Skype, editor, or whatever. Okay, fine. So we'll implement these two functions. So this is essentially going to be an NQ operation, and this is going to be a DQ operation when we talk in terms of the working behavior of the queue. So let's accomplish that. We are going to add the job to the rear end of the queue. So let's have function this star job queue and add job to the queue, and that's gonna be name string, and the ID that we are going to pass will be automatic. We can go with an incremental option. So this dot job equal to append this dot job comma job. I'll say current job. Okay, so that don't get confused. Now, what is current job? Current job should hold the name of the application that's coming in, name of the job or application, however you want to call it. So I need to build current job, and that's going to be job. It needs to hold ID. We could say len of this dot jobs plus one. So initially it's zero, and then string is going to be name. So this name is going to be this name that's coming in. Okay, comma, comma, because it's defined in a new line. Fine. For sake of debug, maybe we can add a debug statement. Printf debug job that is added for scheduling is percentage D with percentage yes. Or maybe we can say is percentage yes with ID equal to percentage. And here we can say name, comma, len of this dot job. Okay, I'll create a sequence here that's going to be len of this dot job plus 1, and that sequence I will call here seq id. Similarly, we can call seq id so that we don't need to compute len of job every time. Okay, fine. Now that we are going to build the multi operation, which is the primary function of the scheduler, and we call it as the scheduling job. So let's say function this start job queue. Now I say this is scheduling job. So this is our scheduler, and this doesn't take any parameter because it just pulls the front element of the queue and schedules it. Okay, from space here, I'll remove it. Okay. Now we check if queue is empty. This is sanity check. Check if queue is empty, and if queue is empty, there's nothing to do. We simply return it. So if len of this dot job equal to 0, simply return it. Maybe before returning, we can have a deep printf statement. There are no jobs in the queue. for scheduling. Okay. If there are jobs, then we schedule it and we take it as hard job for scheduling, schedule job, colon equal to front of the queue. So this dot job of 0. We have got the job now. That's the current job. And we need to schedule it. So what are we going to do? We are just going to print it. In our case, we are not performing any deployment or execution of the job. So just print the job. So I'm going to say fmt dot print executing the job with name and ID equal to percentage D, and that's going to be job dot name, comma, job dot ID. So here it is schedule job dot name and schedule job dot ID. We have previously fixed it. Now we update the queue. So this dot job equal to this dot jobs, everything except front of the queue. So that's one. That's it. We are done. Now this is remove the job that was executed or scheduled just now and leave the queue with the rest of the jobs to be scheduled. This is pull the job portfolio. This is a mimic operation of execution. All right, so we are almost done except for invocation of the jobs and scheduling them. Run queue dot add job. So queue, we can say Chrome. Likewise, we can add more job, Safari, Edge. Basically, we are invoking some browsers and letting them wait for execution in the run queue. So it's going to be VI editor. You can have a calculator. So maybe one more job I'll add is the Adobe application, Adobe Acrobat, PDF reader. Okay, so these are jobs. Now, scheduling task will be first in first out. So we'll have Chrome to first run, and then next Safari, Edge, Vim, Calc, and that's going to be followed by Adobe Acrobat. So run queue dot scheduling job will schedule our job. So this is our scheduler. This is our job schedule. The primary function is executed here. We are just printing here, but normally in a deployment, we could go ahead and send this job for execution on open. All right. We can also implement a list function to see list of jobs sitting in the queue. So we are going to add list to function this star job queue list queue. Doesn't take any parameter, but just list the contents of the job queue. List the job queue. Okay. If len of list is empty, which is a return, so that's going to be len of this dot jobs equal to 0 return. Maybe before returning, we can say fmt dot println queue is empty. Otherwise, we will list the queue. So for job in the range of this dot job, fmt dot println percentage yes dot id equal to percentage d slash n job dot name comma job dot id. That's it. So we will be dumping all the jobs in the job queue. So maybe I can call scheduling job two more times and then call unqueue dot list queue. So I can call it immediately after adding all the jobs. So this should show me all of it. Chrome, Safari, Edge, Vim, Calc, and Adobe Star. And this will schedule Chrome. So basically, you can think of running Chrome. This will run Safari. This will run Edge. And finally, after execution or after scheduling, it would get ejected from the run queue, and the leftover will be Vim, Calculator, and Adobe app. Okay, so far so good. We have all these lines lined up beautifully. Okay, I'll leave it as it is. Let me quickly take a look into the sanity. Yeah, because we are using VS Code, we get to know syntax errors immediately. I'm just introducing a line separator here as well. Looks good. I'll use printf here. Let me comment listing initially so that I get to see the debug statements. And then we'll uncomment it later. All right, so I have saved it. Now I'll open a new terminal. So when I'm running this, you should be able to see each of these jobs getting into the queue and these three jobs at front of the queue being scheduled for execution, and the leftover ones should be only these three after schedule. So I'll run them. Chrome, Safari, Edge, Vim, Calc, and Adobe are scheduling for execution. That's there adding to the run queue, and Chrome, Safari, Edge is scheduled. Perfect. So I'm going to comment this. Add a comment here, fmt.println. This pre-scheduling version, and this list is post-scheduling. So we are able to make out the difference. Now I'll comment the debug statements. I'm not using scheduling job, so I will comment this also. We simply only update the queue, but we are not making use of the scheduled job. Comment this as well. Now we get the same result, but this time from the list queue. Perfect. The same stuff, pre-scheduling and post-scheduling. That's it. So we have been able to demonstrate a basic scheduler using queue and in a FIFO based algorithm. That's it.